The inverse of a function. This is a definition. It says let f and g be two functions such that, we talked about composition of functions yesterday, f composed with g of x, or f of g of x equals x, g of f of x equals x, for every x in their respective domains. The function g would be the inverse of f, denoted f inverse, and f would be the inverse of g. Now, essentially, what in the heck are they saying? If it's f of g of x, now let's think about how this stupid inverse works. That says that, I'm going to write over top of this, I'm going to put my two circles. It says that I have x's. G is going to pick up that x and take it to something over here. We're going to call it y. So g of x is y. And remember what we did yesterday? Then f picked up y and returns it to x. All that's saying is f and g composed together takes you back to wherever you started. Isn't that what the purpose of the inverse was? Takes you back to where you started. Now, if I were to look at this guy, I start out with f. So f picks up an x, takes it over here, and we call that y, so this is y. Then g picks up that value and takes it back. It says, what it does is it undoes what was done. That's your full circle. That's the purpose of the inverse. So that says we can tell the two functions are inverses of each other if f of g of x equals x. So how do we verify that something is an inverse? That's what this is. I let f of x be equal to 2x minus 3. We say, okay, its inverse is x plus 3 over 2. So to check it out, we're going to do f inverse of f of x. It says in the inverse, you're going to stuff the function. So in the inverse, you're going to stuff the function. You pull out the x, because it's x plus 3 over 2. You pull out the x, put in x, and you put in 2x minus 3. Simplify. 2x minus 3 plus 3 is just 2x over 2, or x. Did I end up where I started out? Yeah. Now what I normally do, by the way, is this guy, f of f inverse of x. I don't know, it looks more natural to me for whatever reason. That says in the function f, you're going to stuff the inverse. The inverse we said was x plus 3 over 2. So 2 times x minus 3, so 2 times x plus 3 over 2, subtract 3. The 2's reduce out. You get x plus 3 minus 3, or x, and it checks. Now, in algebra, you don't have to do both, although your book suggests you do both. If you do one and it's x, the other one's going to be x. In our number system, that's just the way it works. So here we go. Verify that, check to see whether or not these guys are inverses. F and G. So I'm going to check f of g of x, which is f of g is x over 6. So that says in the function f, wherever there is an x, I take the x out and I put x over 6, reduce out, And are they inverses of one another? Are they inverses of one another? Yes. So we can then say if f of x is equal to 6x, then f inverse of x is x over 6. They are inverses of each other. Okay. So f of x equals, and I'm going to stuff g into f because that's going to be easier to do. So f of g of x says in the function f, I'm going to stuff g. If they are inverses of each other, what should I end up with? X, because f and g cancel each other out, and you end up with x. So this then becomes f, which is 3x plus 7, or minus 7, excuse me. And this is x plus 3 over 7. What can I almost tell right away? Is there any way I'm going to get x? No. Well, 3 times, this is 3x plus 9 over 7 minus 7. I got to get rid of a 9. I've got rid of 7 on the bottom. I've got to get rid of the 3 on the x. I got to get rid of x by itself. Is there any chance that's going to happen? No. So this is not equal to x. So f and g are not inverses.